All right, welcome back to our final installment of L'Hopital's rule. Here we're going to learn how to handle things that look like 0 to the 0 or 1 to the infinity. Again, L'Hopital's rule doesn't apply. It's not 0 over 0 or infinity over infinity, but we can massage it into a way that L'Hopital's rule will be useful. And here the main trick will be, at least for positive f's functions, you can rewrite f as e to the log f. And that's because e and log are exponential functions. Inverse functions. They undo each other. Anyway, that'll be the main trick. And we'll do an example of each of these so you can see. So, the first example is this. The limit as x goes to 0 from the right of x to the x. This is a fun one. In fact, the fun thing is you can do x to the x to the x to the x to the x forever. That's an enjoyable function. But let's not do it here. So first of all, the x is converging to 0 in both places, so it's that 0 to the 0 form, so no L'Hopital's yet. Let's try our trick. So it's the limit as x goes to 0. We're going to write this x here as e to the log x. So in parentheses here, that's just x. And then we're going to use our exponential rules to say that's e to the x log x. All right. Now, in this case, the trick is this. The exponential function is continuous, so we can move that limit just up here. Okay, if that limit exists, then we're all set. All right, so we've reduced the problem to figuring out this limit. Okay, if we can figure out that, then we can stick it right there and we'll know our answer. Okay, so this one is x is going to 0, the log is going to negative infinity, so it's, well, that one we did before. And the trick for this was simply to write that x as 1 over x, and now it's infinity over infinity, so we can do L'Hopital's rule. So it's 1 over x minus 1 over x squared for the derivative of the top and bottom. So we end up with just 0. So this original problem, back up here, this thing will be e, and that limit was just 0, so the answer is 1. Okay? It's pretty cool, actually. All right, let's do another example, same philosophy, but 1 to infinity. So, the example here, oh, this is a good one as well. The limit as x goes to 0 of 1 plus x to the 1 over x. So, inside it's going to 1, and the 1 over x is going to infinity, so it's a 1 to infinity. Who knows what's happening? L'Hopital's rule doesn't apply. But same type of trick, right? This is the limit as x goes to 0. Okay, just copying the outside stuff. Now this 1 plus x can be written as e to the natural log of 1 plus x. Okay, and then the exponents multiply, so that's e to the log of 1 plus x all over x. And then we can move this limit into the e part up here, the limit as x goes to 0 of the natural log of 1 plus x all over x. So really, if we can just figure out this part, then we'll know the answer. So we come now separately to figure that part out. So it's the limit as x goes to 0 of the log of 1 plus x all over x. Now the numerator is going to log of 1, which is 0. and x is going to 0. So it is 0 over 0. So I can do L'Hopital's rule on it. So I get the limit as x goes to 0, 1 over 1 plus x, technically times the derivative of the inside, which is 1, and then divided by 1. Well, heck, that's an easy limit. The answer is just 1. So that means when we come up here, this side we can plug in now will just be e to the 1, which is fine, but most people just say the answer is e. And this is actually the version that comes up in business, this 1 plus x to the 1 over x. That's how e comes into cumulative interest. Compounding continuously interest. Anyway, there you go. Have fun. See ya.